Hello, all. Good evening. Welcome for the next session on algebra functions and graphs. So, this will be basically a mix of all the concepts we have done so far on algebra. Uh, we know that a function is basically a mathematical input output logic. So, questions of functions and graphs will make use of all the concepts that we have done so far. Uh, and it might be some more concepts will come across also. So a function is basically input output logic, right? And it is defined by an equation, right? So we have already looked at quadratic equations, we have looked at modulus functions. In general, we have looked at polynomial equations, we have looked at indices, inserts, logarithms. All of these are functions, right? And then there are some more functions, such as greatest integer function, least integer function. So there are so many different types of functions, right? Questions will be pertaining to them, right? So let's see what we have. Okay, but before that, I hope all of you are aware of the All India CDC Mock 2. So this is not just a regular test series, it's a mock in which you actually get the real feel of the cat, in terms of, you get to book for an actual uh, slot in an actual designated place that you will go. You'll get an admit card and you'll have a time slot in which you'll get the actual feel of a test center, right? So this is the kind of simulation, the best simulation that you can get of the CAT examination. Sitting just in August, just starting with in August, this is the time that you should get that real environment. So bookings are open, and check out all the details. And I think that this is something that is, uh, you know, you should grab this opportunity. All right. So therefore, let's see let's see what kind of things we can be asked in functions, right? So again, we have mixed of questions, some previous year questions as well. This is the first one. All right, so I'll give you a minute to think on this. All right. We already have done the modulus function, so you can see that it is regarding that. um, I can see a lot of people have joined in today's session, so I'll see if you can get this. All right. All right, let me start to discuss this one. So here, this function is basically, what does this mean? Fx is min of brackets 5 minus mod x and mod x plus 1. So basically, this function, this kind of function has been, this kind of function, questions have been asked pertaining to such kind of function many times, in which a fx, a function, is a minimum amongst two expressions. So these are two separate functions in themselves. One is 5 minus mod x, one is mod x plus 1. So whichever takes the least value amongst them, that is the value of the function. It means the output of this function is dependent on the outputs from these two values. So in order to plot, so first of all, we need to plot such this function. Only then we can understand where can the maximum occur. Okay. So a plot is necessary. Okay. So on the xy plane, how will the graph for this look like? So we need to plot both the functions simultaneously. All right, so let me do one thing. I am first plotting this one, let me call this y1. So this y1 is 5 minus mod x. So minus mod x would have been a function going downwards. 5 is pushing that 5 units upwards, so it will start from at x equal to 0, it will take the value of 5. Then it will be minus mod x, so lines are going downwards like that on either side, right? So that is my graph of y1, which I have drawn in black, right? Mod x plus 1. So we know that this function will be 0 at x equals minus 1. X plus 1 is 0 at x equal to minus 1. So let's call this y2. This y2 will have its 0 value at x equal to minus 1 over here. And then it is mod x basically. So it will go upwards like this on either side. So now with both the functions being plotted across, here is how we can see what the function f1 fx will actually look, right? So I'm going to shade it like this. So you see, before this point of intersection, this graph of f1 of y1 is smaller, so it will be this graph that we'll choose. Then after this point of intersection, the graph of y2 is smaller, it is below f1, it is below y1, so then this function will be chosen. And again, after the second point of intersection, there are 2 points of intersection between y1 and y2. Then again, we will choose y1. Hence, this shaded curve in green is my actual function f. All right. So that is what this function is. With that being the case, we can clearly see that this point of intersection is clearly much above this point of intersection. So this is the highest point, right? Then we can find, so we need to find this point of intersection, right? We need to find the value. So at this point of intersection, can I say that my y1, this is my y1, right? It is positive, means it is in the sense, sorry, uh, this y1, yeah, this y1 is basically, sorry, y1 is 5 minus mod x, right? So yeah, so it is for x more than 0 over here, right? So y1 needs to equal y2. So what will be y1? Y1 will be 5 minus x itself, because x is positive, right? So 5 minus mod x will open as 5 minus x. And how will y2 open? This will equal y2 and y2. So y2 is the mod x plus 1, this graph, right? So this graph again is to the right of minus 1. So again, the mod x plus 1 opens as x plus 1 itself. So we can say 5 minus x equals x plus 1. So we get that 2x, right? X plus x, 2x is 5 minus 1, 4, or x is 2. X is 2, but remember, answer is not the value of x, but the value of fx, which is the value of the y value, the function's value, right? So at x equals 2, what is the maximum value? Put it any, put this value in any which way in either of the two functions. So at x equal to 2, the function value becomes 5 minus 2, which is 3, right? So at x equal to 2, y equals 3 is the maximum value of this function, right? So a function can sometimes be defined like this also, that there are 2 or 3 functions and we are taking the least or the highest amongst them. All right, clear everyone? So today, basically, I have brought a lot of questions in which a lot of graphical analysis will be required. So the way you saw the first question, in which we definitely had to draw the graph and then only we could have understood how to solve. So lots of questions are asked on that. Similarly, looking at the second one. Again, I want some response on this, people. Okay. I just don't want to keep on solving for you. Give me the answer for this. I'm waiting for a minute. How many points do the graph of functions f and g given below intersect? First functions is fx equals 1 minus x square. The second one is gx equals mod of log of mod x. All right. Yes, I know you can do this. All right. Let me discuss in case you get the answer, do let me know, right? I am looking at the chat box. So fx is one. So obviously we need to plot the two graphs on the same plot, and then we need to find the points of intersection, right? As simple as that. The only thing is that 1 minus x square is still easy, but how do we sketch mod of log of mod x? So that is one thing we have to understand, right? So all of us know the graph of log x, basic graph of log x is like this, right? It is undefined for negative values of x, and it starts from negative infinity just near to 0 for x. It is not defined at x equal to 0. For just very small positive value of x, the y value is approaching negative infinity. Then it keeps on increasing rapidly. It passes then through the point 1 comma 0. At x equal to 1 it is 0, and then it gradually keeps on increasing. So that's the basic plot of log x, right? Now, so what about this one, which is a little bit of a variation on that, mod of log of mod x? So take it step by step. First, think of log of mod x. What will that look like? So this is log x, right? When we say log of mod x, it means that when x is, let's say, minus 1, original function log x was not defined, but since we have put log of mod x, so even for x being negative, since mod x, so for example mod of minus 1 will be 1, so the value of, let's say, this function at x equal to um, let's say minus 1 will be that log of 1 itself, which is back to 0. So basically for all the negative values of x, the function will still be defined, and in fact it will not be any random thing. It will be simply a replica of the graph of the function for positive values of x itself. So it will become a function which is a mirror image of this graph itself, right? It will be like this. It will be just a mirror image, because whatever is the value of the graph for positive values, the same value will be there for the negative values. If let's say this at x equal to 10 the value is 1, so at x equal to minus 10 also the value will be again 1. This is log of mod x, remember, this is not mod of log of mod x. Now we further need to take mod of this. So if you have to take the mod of this, then these negative branches will be wiped away, because what is the job of modulus? To convert anything which is negative to positive. So now this is the point minus 1 comma 0. This is the point 1 comma 0, where through which this is log of mod x graph. Now the negative branches will be cut off, and they will be replaced by their positive values, right? So I'm cutting these off, and I'm replacing them with their mirror image about the x-axis, right? Means the same magnitude of value will be replicated, but on the positive side. That is the job of modulus, right? To convert the negative value to the positive value. Mod of minus 5 is 5. So whatever negative values is there, the same magnitude of positive value will be generated. So now this is the graph of mod of log of mod x, right? Now this has to we have to see where and how it intersects with the graph of 1 minus x square, which is a very simple graph, simple inward downward parabola, right? So like this, it will be obviously passing through this vertex 0 comma 1, and it will be going downwards like this, and it will be passing through This point itself 1 comma 0, because at x equal to plus minus 1 it will take the value of 0 also. So it will go like this. So minus 1 comma 0, that is one point of intersection. 1 comma 0, another point of intersection. It will also intersect somewhere around here and here as well. So this is very obvious from the graph. These 4 points of intersection are there. So we have 4 intersections, right? So such kind of curve sketching is something that we need to be familiar with, right? I would say here we had a standard graph of log x that all of us know, and there was some transformation done to that, right? So uh, graphical questions, uh, this is a question based on graph of functions. All right, so that's the theme for today. Let's see what more we have with the next one. I'm looking for your participation, people. So now bringing something on greatest integer function. How many solutions exist for the equation greatest integer of x equals 0.75x, where this denotes the greatest integer less than or equal to x. So questions have been asked many times on this greatest integer function. Now let's see how do we do this. What's the graph of greatest integer function, right? You should all of us should be knowing that. Now, so here it is. So now, so the graph of this is something like this: graph of greatest integer x. Okay. Now, so for x equal to 0 to 1, the value is 0, right? At x equal to 0, the value is 0. At x equal to 1, the value is 1. But just before that, it is 0. So at x equal to 0.999, it is also 0. So from 0 to 1, the value is 0. Exactly at 1, it jumps to 1. So the graph is discontinuous, right? There are sharp jumps in it. So from 1 to 2, as x takes the value from 1 to 2, the output is 1. But again at x, so drawing this circle over here at the end point indicates there is a jump. So the function is not here but on the next point. So from 2 to 3, again excluding 2 3, the value is 2, right? This is 1, this is 2, and likewise from minus 1 to 0 it will take the value of minus 1, right? So from minus 1 to 0, excluding 0, it is taking the value of minus 1, and so on. Now we have to look out for the intersection of, so there are infinite such step lengths, of 1 unit going upward. It's just like a staircase, right? But the vertical lines are not there, only the horizontal lines are there. So greatest integer of x is always an integer value, right? It is not a continuous curve, it's like this. Now for this we are asked how its intersection with the curve 0.5 0.75x, or 3/4 of x, right? So a line with the slope of 3 by 4 passing through the origin. Now, can I say that a line of slope 1 would have passed through these points? 1, because this is 1 comma 1, this is 2 comma 2. So this is a line which is slightly bent downwards. So can I say it is bound to intersect with this horizontal line? It looks very much like that. We can confirm that also. How? Simply, this is the line y equals 3 by 4x. So will it intersect with this line? Well, at this value, y is 1. So y equals the line 3 by 4x. If this line takes the value of y equals 1, what is the value of x? We are getting x as 4 by 3. And 4 by 3, which is 1.33, very much lies in the range of 1 to 2. So yes, we have our intersection point, which is 4 by 3 comma 1. Likewise, will this line again intersect with this line? Let's check. That is what we have to do. So here again, the does the line 3 by 4x. Good, Srinivas. Very good. Very good. Okay, one person has got the answer, but I will just confirm. Srinivas, thank you. So 3 by 4x, for this it should equal to, so x equals 8 by 3, right? So yes, 8 by 3, which is 2.66, lies within 2 to 3. So there is another point of intersection, 8 by 3 comma 2. Now, since we have got so far, we need to also check for the next line above this, which is from 3 to 4, right? From 3 to 4, it will take the value of 3. So will there be intersection point? Let's check once again. At So 3 by 4x, if it is equal to 3, so we are getting x is 4. Now remember, this graph does not lie here. So this line is exactly passing through the point 4 comma 3. But this graph is not passing through 4 comma 3. So this is not a point of intersection. Be very careful. At x equal to 4, greatest integer of 4 is 4. So this is not a point of intersection. See, so we got this, we got this. So is the answer 2? Well, don't forget the origin also. That was also point of intersection. The graph was here at 0. Greatest integer of x is also 0. 3 by 4 of x is also 0. So this is another point of intersection. Behind this, obviously this line being sloping with a inclination less than 45 degrees. So this line will just bypass these lines very clearly. And therefore there are no points over here. So yes, 3 are the points of intersection. Right? So yes, Srinivas, thank you. One person got this. Okay. Well, good, good. Let's see what we have uh, for the next one. Okay. Uh, yes, people, everyone, now gear up for this one. I want more participation. I'm giving 1 minute for this question. Now, let's look. Please try this. All right. So I'm waiting. Nevertheless, so what about this one now? So this is the least integer function, right? This is the symbol, and it is also defined here that it is a least integer greater than or equal to x. So we are looking to the right side of the number line basically. So least integer of, let's say, 2.1 will be 3. Least integer of, let's say, 1 will be 1, right? Least integer value of 2.999 will be 3. So we are looking at the next integer, which is just ahead of the number, right? So we have to just solve this equation. Least integer of x square is 4. So this is basic definition of this is required to understand that if the output is 4, what could have been the input? Now just write x square. X square is the input. What should have been the range of the input so that the output is 4? So obviously we should have been just behind 4. So 3 and onwards, not including 3, right? So x square, the input, should be lying between 3 to 4, inclusive of 4, but not inclusive of 3. Makes sense, right? 3 to 4. So least integer value of 3.5 will be 4, of 3.0001 will be 4, of 3.999 will be 4, of 4 will also be 4. So now we just have to mark the answer for the solution to this double-sided quadratic inequality. Right, x square lies from 3 to 4. Now, taking square root on both the sides makes sense, and square root of x square is mod x by definition of modulus. So basically, mod x lies from root 3 to 2. Sorry, not inclusive of root 3, obviously, but inclusive of 2. This is what it means. Remember, square root of x square is equivalent, or it is simply equal to mod x. So mod x lies from root 3 to 2, or obviously option D makes sense, that x lies from minus 2 to minus root 3 and root 3 to 2, right? So that's the solution to this problem. All right. Well, let's look at some previous year questions now. In the mix, I have brought this one. Okay. Again, giving you a minute to think on that. Very interesting question, isn't it? Will the equation have any real root? Yes, no. Will have roots for x less than 0. Will have roots for x more. So we are making a decision. Will they have any roots? Well, so you can see it's a equation which involves both modulus as well as greatest integer function. Now, how do we manage that? Look at the question. See, in algebra, any question can be done from a pure algebraic point of view, which means we are just algebraically solving the equations with variables and everything. Or we can convert, or we can take the question to the graphical route. We can analyze it graphically. So although the question does not demand, or it does not say anything about drawing a graph or show me this or that, we can convert it and solve it from the graphical point of view, and that will make our life easy. So just say that, okay, this equation can be rewritten, that we are basically looking for, okay, so greatest integer of x being equal to thrice of mod x plus 2, right? Just taking this on that side. What does this tell us? If we plot the two functions, let's call that f1x equals simply the standard function greatest integer of x, and f2x being the standard function which is thrice of mod x plus 2, then f1x equal to f2x is the uh, equation, and from the graphical point of view, there should be the points of intersection between these two curves, isn't it? So let's check for that. We have just seen the graph of greatest integer of x, right? So this is greatest integer of x, like this, like this, like this, right? And also backwards, like this, and so on, right? So this is the function f1x. What about f2x? F2x is simply 3 mod x plus 2. So at x equal to 0, it is 2. And it is going upwards with a slope of 3 on either side. 2 plus thrice of mod x. So do you see the disparity between these two curves? How greatest integer of x is just lying below this function. There are no points of intersection. Impossible. Because these two lines are going upwards at a slope of 3. How can they ever touch? How can this graph ever catch up with that? Because this is a graph which is always lying below the line y equals x, right? It is always lying below or at the level of y equal to x, and that line is 3 mod x plus 2. So no point of intersection ever, isn't it? Isn't it a very interesting thing to look at a question from the graphical point of view? right? So think graphically whenever the algebraic perspective becomes difficult. That's the moral of the story. Okay, now a very similar question to something we have discussed earlier, right? So I'm starting this. In case you get the answer, do let me know. It's a theta question. You have to. So it's a theta question. As we know, a lot of questions in CAT are now type in the answer type. So let fx equals minimum of 2x square and 52 minus 5x. So these are the two functions, and we have to choose the minimum amongst them. Remember, however, x is any positive real number. So we only have to plot this graph for positive values of x. That is the domain of the function, right? Then what is the maximum possible value of the function? I think we can do this. There is a quadratic, there is a linear, right? So let's see who is quick. I'm starting this. If you get the answer quick than me, faster than me, then you get the points. Okay. Well, so 2x square. So it's a simple parabola. It's a simple parabola, and we'll only draw for x more than 0, right? It's a simple parabola passing through region 2x square. And the other one is the line 52 minus 5x. So starting from somewhere at x equal to 0, it is 52, and then going downwards with a slope of minus 5. There's bound to be a point of intersection somewhere, right? So with that, again, let me shade the graph. So first we'll choose 2x square because that is below the line. But after that, a line is below the quadratic, so we'll choose the line. So simply this point of intersection is the maximum point, right? So in all these questions, whenever this maxima minima value is asked, that is typically the intersection point, and always it is the intersection point. The only thing is that when there are multiple points of intersection, then we have to choose from those that where does the overall maxima minima occur, right? Like in the previous question that I took, we chose from the two that, okay, this one was maximum, right? Now this is the only one, so we just have to solve for the equation that these two are equal. So we have to just algebraically solve. Remember, there also we solved for the equality, but there the equality happened as per the given condition because there was modulus of x. Now here we have simply algebraic expressions, so we need to solve therefore for 2x square being equal to 52 minus 5x. Right, so we just need to solve this quadratic. 2x square plus 5x minus 52 is 0. Looks like we have to factorize this. There must be an integer solution because it's a theta question. We never get theta questions with fraction as the answer. So look at the product of the constant term and the coefficient of x square, which is 52 into 2, 104. 104, we are trying to break it apart into two factors whose difference is 5. I'm doing the splitting of middle term basically, right? The idea being 52 into 2, 104, should be expressed as a product of two factors which differ by 5. So yeah, 13 into 8 is 104. So yes, the factorization, it becomes 2x square plus 13x minus 8x minus 52. So yes, this factorizes as x minus 4 because here I'll take x common, here I'll take minus 4 common. X minus 4 into 2x plus 13 is 0, right? So x is either 4 or minus 13 by 2. We'll reject minus 13 by 2 because we are only looking for positive values. So at x equal to 4, the maximum value is obtained, and that maximum value is nothing but f of 4, and f of 4 is simply the value of the function at any of them. Choose any of them, it's the same value. 2 into 4 square, 2x square, 2 into 16, 32, right? Or 52 minus 5 into 4, 52 minus 20, that is also 32. Perfect. Okay, so uh, you can see that these kind of things, and it was CAT 2018, quite recent. Okay, let's take one last problem for today's session. um, and I feel this is one of the most logical questions on functions that I've seen in many years. I would want you to think on this for a minute, please. CAT 2020 problem. Let me see if anybody get this. All right. So, what about this one? Now, you can see this equation, right? And it is given that function has four distinct roots. We are asked to find the sum of the roots. Now, what are roots graphically? They are simply the points of intersection of the graph with the x-axis, right? Any curve going like this. So this is the root, this is the root, means the values of x at which fx equals 0. The y value becomes 0. The point of intersection with the x-axis are the roots. So it is given that this function has four roots. So maybe x1, maybe x2, somewhere we have x3, we have somewhere x4. Right? Now, what does this tell us? F of 5 plus x equals 5 minus x. This has to be used to be able to find the sum of the roots. Very interesting. Now, you see, this is a standard, I mean, res, functional. This is basically an equation, a functional equation, right? A equation which is always valid for a given function is called as a functional equation. Now, this basically, is a standard notation. So I'm just writing in general, if we have this, that f of a plus x equals f of a minus x, let's understand what does this mean. So here a is 5 and we have something like this written over here, right? F of a plus x is f of a minus x. So basically for any function, this being the x and the y axis, and now for x equal to a, for the vertical line x equal to a, this equation is basically telling us that the value of the function to x units right or left of the line x equal to a is the same. In other words, the function is having its symmetry around the line x equals a. It is the graph on either side are mirror image of each other. Right? This is the equation which tells us the symmetry of the function around x equals a. So maybe the graph can be like, let's say, this. If it is like this over here, then it should also be like this over here, the mirror image of that. Okay. Now, it is given that this function has four roots, four distinct real roots. So try to understand. Let's say this is the first root over here, x1. Okay. And this is the other root over here, x2, which is the mirror image of that. So just think about this. If this x1 is something like 5 plus some quantity, 5 plus, let's say, m. So we have moved m units to the right of 5. So we should have also moved over here 5 m units to the left of 5, and this other root should be 5 minus m. So can I say the sum of these two roots, x1 and x2, is 5 plus m plus 5 minus m? Are you now understanding? Yes, we are getting the answer. We are getting close to the answer. The sum of these two roots is 10, irrespective of where these roots are actually situated, since they are symmetrically around x equal to 5. So the sum of these two roots should always work out to be 10. Right? Now, we can't say what these roots are actually. They might be 6 and 4. They might be 8 and 2. They might be 12 and minus 2. The same distance to the right and to the left of 5, and the similar thing we can say for the other two pair of roots also, x3 and x4, something like 5 plus n and 5 minus n. So the sum of the other two roots also works out to be in a similar manner 10. Hence the sum of all the four roots, x1, x2, x3, x4, works out to be what? 20. Nice. So you see how a graphical interpretation was required, right? That is the theme of today. Graphs are related to functions, right? So think graphically with function problems. All right, so that was our meeting, and we'll continue this. Don't worry, we'll be meeting again on this. So the topic of functions is a bit vast. So today we have focused on the graphical approach based problems. So there are other questions of functions also, which are purely algebraically based. So we'll continue with that. So yeah, thank you so much. See you in the next session, and stay connected. And don't forget that our Race to 99 event is just around the corner, August 2nd and 3rd. All our mentors will be there for you to guide you. This is the schedule that you can see over here. Uh, so I'm sure that you'll be looking forward to this event. So hope to see you there. Thank you, people. Thank you so much. See you the next time. Thank you. Thank you all.